Good afternoon, everyone. I'm Thanu. I work for Oracle and currently working on OpenStack Trove on Solaris platform. So today we are going to present about the OpenStack Trove database for which some of the deployment reference architectures. And essentially these are recommendations to the users that they can use while deploying Trove. So initially we are going to talk about briefly about the Trove architecture overview, and then a recommended neutron network setup that I have set up. And after that I'll be handing over to Amrith, who will be talking about the reference architectures that are used. So Trove is a database as a service component of OpenStack, and Trove instantiates database instances, and at the same time Trove manages the database instances as well, databases as well. So if you see the left side of the box, it essentially works similar to the other OpenStack components. The request that comes from the horizon or the CLI, the entry point is the Trove API, which has a bunch of RESTful APIs to manage instances and also perform database operations. The DB is the model repository for Trove itself. It stores information about Trove instances and the databases that are created on those Trove instances. And Trove Task Manager is a RPC-based service which essentially picks the request that the Trove API is placing on the message bus. And the Trove Task Manager, depending on the type of request, either goes to the database to fetch the results, or it hands it over to one of the OpenStack components like Nova. And Trove Conductor is the one which talks to the Trove guest agent to get the work done through the guest agent. So just to see how all these pieces work together, we can just take a quick tour how Trove create command essentially works. So before even invoking Trove create command, the user has to build a guest image which he has to upload on the glance. The guest image is nothing but the base OS plus the database server that he wants to install, and also the Trove guest agent package, and few other packages that are needed for the Trove instance to work with Trove. So such a guest image is uploaded to the glance, and when you get the glance ID, that is registered with the Trove infrastructure so that Trove knows what kind of image it has to install. So when a Trove create command is passed, it essentially takes a few essential parameters apart from other things like the image ID, the flavor, and the network information, and also the files to be injected onto the instance. So such a request is placed on the message bus, and the Trove Task Manager picks up the request and sees that it's a Nova instance that needs to be created. So it creates a Nova instance, and while creating the Nova instance, the Cloud-based init comes up, and the Cloud-based init, Cloud init on Linux and Cloud-based init on Solaris. So this essentially picks up the metadata from the metadata service and launches the guest agent, and the guest agent sends heartbeat to Trove Conductor, and Trove sets the instance as active. So this is the quick tour of how things work on Trove. This kind of a setup can be made in any kind of environment, like the Trove instances can run on the same node where other infrastructure components are running, and the network can be the same, and the Trove, there are no restriction about using separate RabbitMQ for Trove. But we would like to recommend certain things to the customers as to how this kind of a setup has to be made. So one thing is network isolation has to be done between when the Trove guest agent talks to the Trove infrastructure, it should be an isolated network because Trove is one of the components which makes things on a guest agent talking to the infrastructure, and also a dedicated RabbitMQ has to be there. So we just made this kind of a setup which we plan to recommend to the customers. Here, as you can see, that the Trove infrastructure is running on one of the nodes, like where along with the OpenStack components, and the Trove RabbitMQ is running on a separate Solaris kernel zone. It can be any separate entity that can be lightweight too, like a non-global zone too. So the Trove RabbitMQ has two network interfaces. Net 0 talks to the service tenant where the OpenStack services are running, and the net 1 will be talking to the through a shared neutron network with the instance that will be spawning. So this way the network is isolated and also the RabbitMQ is separate. So this is one of the recommended way to do this, but there are multiple ways. With that, I hand over to Amrith to talk further on the reference architectures.
Thanks, Thanu. Thanks, Thanu. My name is Amrith. I'm the PTL for the Trove project. I'm sorry there's a little bit of an eye chart, but I'll try and describe to you what the various components which we're showing here are. As Thanu mentioned, with Trove, you provision databases in virtual machines, by extension also in ironic bare metal, and soon to be in containers. In that machine, you will have a database, whatever database you choose, one of about a dozen which we support right now, and your application talks directly to that. Now, since your application is talking directly to the database, that virtual machine, let's just talk about virtual machines, that machine needs to have a network port on your tenant network. That's where your application is running. It's going to talk directly to the database. I don't know if you guys can hear me, but I'm hearing more of myself than I'd like. If you could reduce it a little bit, like, okay. So the Trove database itself is going to be talked to directly by the application. The guest agent, which is the piece which is running on this virtual machine, which does all the database specific stuff. Things like, for example, take a backup of a database. Trove supports a backup for a dozen different kinds of databases. It's the same API call. So the guest agent needs to understand how to do backups for each individual database, and for that it needs to talk to the control plane. So what you're seeing here on this picture is a collection of OpenStack services down here at the bottom. At the bottom, there's also an infrastructure RabbitMQ, which is set up for HA. And on the top, you notice there's some compute nodes, but in the middle, in one of the Nova compute nodes, is a VM, which is running your actual database. That VM is then plumbed onto a management network and a tenant network. That's the basic architecture which you have. We're going to go into a lot more detail about this in a session right after this. If you're interested, it's in room 117, so come on over there. This is a very simple architecture which is suitable for a POC. When you're operating in production, this might not be the way in which you want to operate things. Why is this good for a POC and not in production? Well, for one thing, you're having everything on a shared set of resources, and that's not particularly a good way in which you want to run Trove in general. You may want to have your OpenStack controller and all of your OpenStack control services run in one infrastructure database, one set of RabbitMQ, but a different one for Trove. Those kinds of separations are possible in other architectures, so we'll talk about some of those. So in the POC architecture, we primarily give you an isolation between anything which Trove has and the rest of your OpenStack. Now, why is this a good thing? You've got OpenStack up and running, but you want to try out Trove. So the easiest way for you to do that would be spin up a VM with Nova and run Trove in that VM. That's the kind of architecture we have here. Easy for you to get up and going. The important thing to remember is, like the picture with Thanu showed earlier, Trove is a consumer of other OpenStack services. So we consume Nova, we consume Cinder, we consume Swift, we consume Glance, Keystone, Neutron. As long as the Trove controller is able to talk to the public API endpoints for all of those services, we're fine. You can put it in a VM, it's great. That's not how you want to run in production. So when you want to run in production, you start doing a couple of other things. Another good benefit of this particular approach is we've found a lot of people are still running OpenStack version, I don't know, Kilo, OpenStack Liberty. The latest features in Trove and Newton may have different requirements from the underlying platform level. So if you take Trove and just drop it into a VM, you have no issue with requirements and compatibilities. Great place to start for a POC. Now, when you want to move on into a production, you have slightly different set of things. Notice here at the bottom, all of your key OpenStack services, Keystone, Neutron, Glance, Swift, Cinder, Nova. And here you notice that Trove is running in the same control plane with the rest of the services. With the exception of that, The rest of the architecture remains virtually identical. The virtual machine or the bare metal instance will be on the tenant network and on a management network. Here, all we've done is we've moved Trove from being on an independent VM running its own private infrastructure onto the OpenStack infrastructure. So primary difference from the POC, we're moving Trove into the control plane, and we're also, this is the most common one which we're seeing people use in production. And there are a whole bunch of different ways in which you can deploy Trove. I think we're a little bit short on time here, so I'm not going to go into a lot more detail here. The primary things which are important for you to keep in mind is that the Trove controller needs to be on the management network in order, the Trove controller, which is on the management network, and the guest instance need to be on the same management network so the guest agent can communicate with it. That's the primary thing to keep in mind in all of your architectures. The important thing which you have to remember is that at this point in time, the way Trove runs, that's one common cross-tenant management network. So you may need to have security groups on that to make sure that tenant-to-tenant crosstalk does not happen. So that's all I think we have time for here, but there's a session in room 117 right after this if you're interested in learning more. Thanks a lot.